Welcome to lecture 9 of the course CS213 Object Oriented Programming of the Kohat University of Science and Technology. This will effectively be lecture 9 of the course, and in this lecture we will discuss inheritance in a bit of detail. We will look at an example of inheritance, and we will see what are the benefits or advantages of when we use inheritance. Inheritance, as we understand that, is an important concept of object-oriented programming, and it helps us in reusing some of our existing code. Before we go into the details of inheritance, let's see what we have done so far. The topics that we have covered so far include introductory topics to object-oriented programming, a bit of syntax of the language that we are using, and we understand that we are using Java for this course. We have studied classes, objects, constructor, what is a constructor, and our last topic was composition. These topics were covered in detail, and the examples of these can be reached at the web page of the course, piazza.com, as we can see on the screen, and the relevant program and examples and the notes that we have covered can be accessed through this Piazza page. In this lecture, we will have an introduction to inheritance and try to understand what basically inheritance is and what are the situations where we can use inheritance. For example, when we need to share common code between the classes, then that can be a situation where we can take advantage of using inheritance. The other related topics that are, and maybe we won't be able to cover all of these topics in this lecture, but we will be following these topics in the upcoming lectures. For example, we will revisit our understanding of constructors, and we'll try to understand how the behavior of constructors change when we use inheritance. We will also revisit the access modifiers that we have discussed earlier, the private, the public, and protected. Now that we will study inheritance, we'll try to understand again that how some of these access modifiers can be used and the situations where they can or cannot work. We will discuss method overriding, and also, if we get a chance, we'll talk about the object class, that is the superclass of every class in Java. The book for this course, as has been discussed earlier, is Java How to Program, the early object version of the course, Detail in Detail, as we know, and the relevant material for this lecture is chapter 9. You can also follow some of the tutorials that are available online if you find them useful, and we can see some of the relevant topics that are relevant to inheritance, and we will be covering these topics. But if you want to have a look into these topics, then we can see that there are polymorphism, overriding, hiding fields through access modifiers, using the keyword super, and object as a superclass. As I said, that we'll be discussing these topics in detail, but these are some of the relevant topics of inheritance. Inheritance is a situation where a new class is created by acquiring an existing class's members and possibly adding them with new or modified capabilities. So when we have a situation where we can reuse some of the existing code, some of the existing class, where we can take advantage of some of the existing code, then Java or any object programming language provides us with the concept of inheritance, where we can use inheritance. Now, when we use inheritance, we can add to the existing classes capabilities, whatever it can do now. We can add something additional to the existing class, and we understand that the classes members, there are data members which we depict through the instance variables of a class, and then there are methods within the class, and we will see that we can maybe inherit all of these resources that our class currently has. The situations where we will need depends that how much and what resources can or shall we inherit from the existing class. But once we have inherited a class, the existing class in that case will be called the super class or the base class. That will be the class that is already there, and we are using this class's code in another class. This class will be called the super class or the base class, and the newly created class will be called the subclass of the super class, or it can also be called the derived class. A parent-child relationship is created between the two classes, where the super class can be called the parent class and the subclass can be called the child class. And through inheritance, the subclass inherits the capabilities or the data members and the functions or methods of the superclass. Why do we need to use inheritance? It can save us time. It can save us the development time. Instead of rewriting the code, we can reuse the code. We can simply inherit the code into a new class, and it can also save us from debugging an already existing code that we have. It might be a good quality software that we have, and instead of rewriting the entire code, we can reuse this code with additional capabilities. There are many examples where we can use inheritance. For example, if you are asked to add an additional program to the existing KCMS system, and the university requires, for example, the university wants to start a new program, and if you are asked to make the changes to incorporate the new degree program into the existing software, there are maybe two ways of doing this. One is to create the entire software and try to add the new additional details into it. That will obviously take a long time, and it will take a lot of resources. What we can do is to create a separate software for the new program, which will not help the university a lot running two parallel programs. What object-oriented programming provides us is to use inheritance in such a case, where we have an existing system like the KCMS, which has been debugged and it is running fine. So what we can do is we can inherit the existing capabilities of the KCMS system, and we can add to the existing system by inheriting these details into our newly created program. So our newly created program will have the existing capabilities of KCMS, as well as it will incorporate the new details that are required by the new degree program. It increases the likelihood that a system will be implemented and maintained effectively. And for example, again in the KCMS system, if we reuse the existing code and we try to add to it instead of recreating it or running a parallel program, it will easier for the university that the new system can be implemented rather easily or efficiently than recreating a new system. And the maintenance of the newly created degree program will be easier if the university has one single system to deal with in the entire degree programs that the university is running. There can be multiple examples, and we will see at other examples. Like for example, we go to the bank, we can add multiple kinds of bank accounts, but our details, let's say our personal details, remain the same for those accounts, whichever account we want to open. We'll see for more examples of inheritance in the upcoming lectures. And what happens is that once a class is inherited, the derived class or the subclass now in this case takes over or inherits the attributes and behavior of the latter, that is the superclass. The attributes we understand that are depicted by the instance variables of the class, and the behavior are depicted by the methods inside that class. We can in Java the functions are called the methods. So these are inherited or taken over by the subclass, which means that we can access the attributes and the behavior of the superclass in the subclass now, and we will see through when we look at access modifiers that we may not be able to directly access the private variables of the class, but we have seen previously that we can access the private data members through the public methods within that class, and we'll see this in the examples in this lecture again. So for example, we have a class person, and the person has these details. We can see at this UML diagram, and the person has these details. For example, the person has the class diagram for the person has the first name, the surname, and an ID number, and these are all of type string. The person also has a couple of constructors and some of its own methods that we can use to try and access the instance variables of the person class. We can see that the variables of the person class are protected, and the methods of the person class are public. Now we have another class, the employee class, we can understand that an employee working in any organization will at least have the details that are currently there in the person class. So for example, anybody who is working no matter what kind of organization, that employee is expected to have a first name, maybe a last name, and some kind of a notification number. Each individual in any country has the citizenship number of that, is expected to have the citizenship number of that country or that location, and we are expected to have a name when we are born, so it can be called the human right of a person to have a name and have some kind of identification. So the employee is expected to have these details. Now, and there are some additional details of the employee as well. If we try to use these in separate classes, so employee is one class and the person is the class that we already have, we can inherit the details from the person class into the employee class along with the details that the employee class already has. So the employee class has an annual salary as a variable, that is a private variable, instance variable, and it has a constructor and it has a method for getting the salary of the employee. What the employee also has is that it has access to the details in the person class now, because the symbol, that arrow that is showing here, is showing an inheritance relationship between these two classes, and that is where we can use inheritance to reuse the existing code in the person class. These are the methods that are inherited from the person class by the employee class, along with the details of the employee class. So the employee class now have an additional method, get salary, along with the get ID and get names of the superclass. So the employee class has access to the superclasses method, and it has additional method of the get salary. When creating a class, rather than declaring completely new members, you can designate that the new class should inherit the members of an existing class. So for example, when we have inherited from a class, instead of recreating or declaring the members again, we can directly inherit those members from the superclass. So for example, in the previous example that we saw, the person had a first name, a last name, and an identification number. Instead of declaring these details or these data members again in the subclass, the employee class, what we did was we inherited those members into the employee class along with the methods of the person class. And we also saw that we can add our own variables and methods. For example, we added the salary variable for the annual salary in the employee class, as well as the get salary method, an additional method, the get salary. So now our employee class has the first name, last name, and ID number, as well as get salary, annual salary as data members, and it has the get ID, the get names, and the get salary as methods. And this is something we'll look into detail in when we study method overriding. But the subclass can change the meaning of the inherited methods that are specific to the subclass. So for example, there are methods in the superclass that are inherited by the subclass and are needed by the subclass. What the subclass can do is it can redefine those methods within the subclass. It can inherit those methods and change the meaning or add something to those methods. And we will see this in detail when we study method overriding, as to how an subclass can change the methods of the superclass and can add to those methods or even completely redefine them in fact. As we saw in the example, a subclass is more specific than its superclass and represents a more specialized group of objects. So let's say a person can be an example of anybody that has a name which maybe it can be anybody in the world, that all the humans can be classified or categorized into the person class. Everybody is expected to have a name and some kind of identification. So that is a general example of anybody who has some common details and that can be categorized into a person class. But when we talk about, let's say, employee or a student or a player, maybe, all of these are examples of people, all of these are examples of a person. But as we call the names, let's say an employee, which suggests that that might be somebody working in an organization or somewhere. And when we say a student is expected to be studying in some kind of a school or a college or a university. That is the definition of a student that we understand. Or a player, maybe plays is a person, but is a special kind of a person who plays a game. So employee is a person, but is a special kind of a person who works somewhere. Student is a person, but is a special kind of a person who studies somewhere. Similarly, we can say that a current account is an account, but it is a special kind of account. And a savings account is an account, but is a special kind of account where it has the capabilities of an account, but it has some of its own additional details. In all of these examples, we can see that we are going from generalization towards a specialization. So a subclass is a more specific version of its superclass, and they represent more specialized groups of objects, as we saw in the examples. And Java is a completely object-oriented language, which means that every class in Java is inherited from the object class implicitly. Now, so far we have been using classes and we were not inheriting those classes from any of the class. And apparently there was no superclass of the classes that we have been using so far. But what Java does is, whenever we declare a class, it implicitly inherits that class from an object class. Object class is a built-in class that is a superclass of any class that currently has no superclass. That is an implicit superclass of any class in Java, and we will see that in detail in the future lectures. Object has its own methods and we can access, and actually we have been using the toString method. The toString method is a method that is defined in the object class, and we have been able to access and inherit that method from the object class implicitly in our examples previously, but explicitly we have not used object as a superclass, and we'll see in the example in the next video that we can extend our existing class from the object class, and syntactically it will make no difference, but we'll look at an example where we inherit from the object class and our code will work the same, because that is something Java does implicitly for us. And as should be understandable that a subclass can be a superclass of future subclasses. Like say we have inherited an employee class from a person class, then we can have a special kind of an employee that is inherited from the employee class. Let's say for example we will look at an example in the book, that is a commission employee is inherited from the employee class, or a salaried employee is inherited from an employee class, or contractual employees can be inherited from the employee class, and these classes can go further down in the hierarchy. So Java allows us to indirectly inherit from as many classes as we can in the hierarchy, but Java supports only single inheritance, which means that we can directly derive from only one superclass. We cannot directly derive from multiple superclasses, and we'll see this in the example in the next video as well, that we cannot inherit from multiple classes at the same time. In Java supports only single inheritance. We can go down in the hierarchy as much as we can. So for example, we have a person class as a superclass, then we have the employee class as a superclass. The employee class can be a superclass to a commission employee or a salaried employee, but the employee class cannot inherit, for example, or a commission employee cannot inherit at the same time, for example, from the employee class or some another class like a person class directly. It can indirectly inherit from the person class, but directly Java does not allow us to inherit from multiple classes. And maybe we can work around this when we use interfaces, but that is something for the future lectures. Has a versus is a relationship. If you remember from our discussion on composition, and in composition we saw that there has a relationship between the classes, and the has a relationship was when we said that an employee has a birth date or an employee has a hire date, which suggests that a certain class can have another class or the object of another class as its instance variable. In inheritance, we can see an is a relationship between the classes, as we saw that an employee is a person, or a student is a person, a current account is a class, or a savings account is a class. So we can see an is a relationship between the classes as opposed to a has a relationship that we have seen in the composition relationship. In an is a relationship, an object of a subclass can also be treated as an object of its superclass, and we'll see this in our examples in the upcoming videos. Has a relationship represents a composition relationship. In has a relationship, an object contains as members references to the other objects, and we have seen this in detail. This example where a house is derived from the building, this arrow should always be towards the superclass. So we are deriving from the building. The house is a building. We can see that house is a building and house has a bathroom. So there is has a relationship between the bathroom and the house, but there is a relationship between the house and a building. But when we look at the inheritance, in inheritance we have an is a relationship. So a teacup is a cup, or a coffee cup is a cup. And we can also see that we are indirectly inheriting from, let's say, the coffee mug is a coffee cup, which in turn is a cup. So a coffee mug is a cup again. This is the kind of inheritance that we were talking in the previous slide, that a subclass can be a superclass of its own subclass. So we are indirectly inheriting from the cup. The coffee mug, let's say, is indirectly inheriting from the cup, and it is directly inheriting from the coffee cup. Similarly, a teacup is a cup, an espresso cup is a coffee cup, which in turn is a cup. So we can see an is a relationship in inheritance and has a relationship in composition. We can also see that we are going from generalization to specialization when we go downwards in the hierarchy. So a cup is can be any cup, but a coffee cup is a special kind of a cup. Like we can have a green tea cup. We do have the green tea cups maybe in our homes, or somebody can have their own special kind of a cup, a birthday cup or some other kind of cups. So these are special kinds of cup. A coffee cup is a special kind of a cup. A teacup is a special kind of a cup, and a coffee mug again is a special kind of a cup, that is a coffee cup, but is a special kind of a coffee cup. So we are going towards specialization from generalization when we go downwards in the hierarchy. Similarly, house is a building, but is a special kind of a building. There can be other buildings, like a hospital is a building, like maybe school is a building, a university is a building, it has a building, so it can be a building. And we can have multiple examples of buildings, but house is a special kind of a building. So we are going from generalization towards a specialization. Superclasses and subclass we can see with the help of these hierarchical diagrams. A superclass exists in a hierarchical relationship with its subclasses, and as we saw in the previous slide as well, that when a subclass inherits a superclass, the subclass can further be inherited by its own subclasses, and we can go downwards in the hierarchy, as we can see in these two examples over here. Each arrow in the hierarchy represents an is a relationship. So employee is a community member, faculty. This diagram shows us community, the diagram of a community of a certain university. So these are the kind of people that can be there, possibly there in a university, or can be part of a university. If we call any member of a university as a community member, then there are employees in the community. There can possibly be students. So as many classes can inherit from the community member class. But at the same time, if we try to inherit from the student class, if the staff, which is a subclass of the employee class, if it tries to inherit from the student class, the Java will not allow us. Or if it tries to inherit from an alumni class, the Java will not allow us to do this. Now we understand that a staff member can be a former student of the university, but currently in Java we cannot directly inherit from more than one classes. So we can technically we cannot do this. We cannot have this kind of a relationship between the staff and the alumni, or the staff and the student classes. The teacher intern can inherit from the faculty, or an administrator can also inherit from the faculty. So administrator can be a faculty member who is currently not assigned with the teaching responsibilities, maybe some the head of the department, or some other faculty members who are assigned with the administrative responsibilities. They can also be part of the faculty, and teachers are part of the faculty. And in this case, the teacher is a subclass of the faculty class. So that means that it will inherit the details of the faculty class, which in turn will inherit the details of the employee class, and that will inherit the details of the community member. So the teacher is a subclass of the faculty class as well as the employee class and the community member class, and same is the case with the administrator. In this case, it will have access to the faculty classes members as well as the employee classes members and the community member classes members. And the same is true for this diagram. The shape class is the superclass, and there can be two-dimensional shapes or three-dimensional shapes which can have their own classes of shapes. For example, we can have circles, which is a subclass of the two-dimensional shape. We can have a square, which is a subclass of the square, the two-dimensional shape. And we can have a triangle, which again is a two-dimensional shape. And at this side we can have a sphere, a cube, a tetrahedron. These are examples of the three-dimensional shape. And starting from the bottom, you can follow the arrows and apply in the is a relationship to the topmost superclass. As we said that the classes at the bottom will inherit the details of all the classes that are above in hierarchy from that class. And triangle is a two-dimensional shape and is a shape. A sphere is a three-dimensional shape and is a shape. So these diagrams explain the is a relationship between the classes, the superclasses and the subclasses. We'll look at an example, example implementation, which will explain the concept of inheritance to us in more detail. So see you in the next video for lecture 9.